Hello everybody. In this video, we'll be going through questions 11 through 15 of the SMO Junior 2020. Question 11 is a geometry problem which has to do with the areas of triangles. Let's draw the diagram first. Without drawing a diagram, it's really hard to tell what the question is even talking about. So ABC is a triangle, D is the midpoint of BC, and E lies on AC such that AE to EC is 3:1. Now let F be the intersection of AD and BE. The area of ABC is 280. That's the whole triangle, and we are asked to find the area of BFD, which is this small triangle over here. Now 280 is the area of the whole triangle, so when we want to find the area of BFD, essentially we are just trying to find how much of the whole triangle it is, i.e. this question is to do with ratios or fractions, depending on how you look at it. So BD equals to DC and AE to EC is 3:1 would be the two things that we have to make use of. We have to make use of them in as complete a manner as possible in order to make progress. So let's write down what BD equals to DC means first. Well, BD equals to DC, it means that the area of triangle ABD is equals to the triangle ACD's area. And since these are both half of the triangle, that means that their areas are each 140. Also, we can say that the midpoint also tells us BFD has the same area as CFD. That means two things. First, it's probably a good idea to call this area X. And secondly, since CFD is not yet marked out in the diagram, I think we should certainly add this line. So both of these areas are X and X. And I can label ABF to be 140 minus X. Now, AE to EC is 3:1. Likewise, I can say a couple of things. I can say that ABE is 3 times of CBE. Because now, these two triangles here have the same height, but the bases are in the ratio 3:1. Since ABE and CBE split up the whole triangle ABC, we can say that ABE is 3/4 of the area, which is 210, and CBE is 1/4, which is 70. Again, this means that I can write down 210 minus 140 minus X. So AFE has area 70 plus X. And CBE has area 70, so 70 minus 2X will be the area of triangle CFE. Now the last statement that we can obtain from AE is 3 times of EC is that triangle AFE is 3 times of triangle CFE. And this is going to give us an equation for X which we can solve. 70 plus X is 3 times of 70 minus 2X. So if we solve this linear equation, X is equal to 20. Now the key to this question is to make full use of the ratios and the midpoint. So if you want to make use of the ratio fully, it is not enough to just use it for one pair of triangles. We try to use it for 2 or potentially even more if the figure was more complicated. So that would also guide us into drawing this line CF, which was not originally indicated in the diagram. Moving on to question 12. This is an alphametic or cryptorhythm. Either name is the same. And what it means is that each of these letters represents a different digit from 0 to 9. The question tells us that k is 6, so we do know one of these letters. And it asks us to find shake, which means that we essentially need to find all the letters in this sum. Now, for a cryptorhythm, it makes sense to start with the easiest and most informative clues so that we don't have to break up into multiple cases immediately. So it's something like a Sudoku. You want to start with everything that you can logically deduce, and only if you're really stuck, then you make a guess. But you don't want to make a guess immediately, because after doing a lot of work, if your guess is wrong, then you've gotten nowhere. So the two most straightforward clues are E plus E ends in E, because this can only be E is 0. And then K plus K gives you L, so 6 plus 6 is 12, so L is 2, and there's a carryover of 1. Now there's something else that we can say immediately, which is also considered obvious if you're familiar with cryptorhythms, and that is S plus S. These are 5-digit numbers that sum to a 6-digit number, so R here must be 1, because the two numbers added up cannot exceed, they are less than 200,000, so the first digit must be 1. So R is 1, L is 2, E is 0, and K is 6. So the remaining digits which we can use would be 3, 4, 5, 7, 8, and 9. Let's take note of what these 3 remaining place values tell us. Firstly, we see that 1 plus A gives you T, possibly with a carryover. Next, we see that H plus H gives you T, possibly with a carryover, and then S plus S gives you RA, where R is 1. So we need to find out whether there is any carryover, because that would indicate what your possible values of A, H, T, and S are. So let's write down what each of these say now, with the contingency that we're not sure whether the carryover is included. So for A and A, we know that 1 plus A plus A is equals to T, possibly with 10. So when I say a question mark on the right hand side, it means that maybe there's a carryover. Now depending on whether there's a carryover, that would add up to question mark plus H equals to T, and again with a possible carryover. And finally, depending on whether there's a carryover here, this unknown carryover plus S would be equals to 10 plus A. So this one, there is definitely a carryover. Now how do we tell whether there is a carryover in each of these two possible cases? Well, one way would be to split up into cases, and that would be certainly possible, although slightly unhelpful, because we would have 3, 4, 5, 7, 8, 9 as 6 possible values to try for A, and that seems a little bit slow. An important observation that we can make is that 1 plus A over here is definitely odd. So if it's definitely odd, that means that whether or not there's a carryover, T must also be odd. Now if T is odd, and we look at the second equation, H plus H cannot give you T. H plus H cannot give you T plus 10 either, because H plus H is supposed to be even. So the only conclusion is that this question mark must be 1. In other words, there must be a carryover of 1. And that comes from 1 plus A is T plus 10. Now we can revisit these equations now and look. 1 plus A is t plus 10. So 1 plus h cannot also be t plus 10. Otherwise that would mean A and h are the same. But each letter is supposed to mean a different digit. As a result, this means that there is no carryover here and no carryover here. So that doesn't leave us with too many things to consider, because 1 plus A has to carry over 10. So A can only be 5, 7, 8 or 9, because you need a carryover. However, in the last one, S plus S equals to A plus 10. So that means that A is the last digit of S plus S, so A must be even. Now combining these together, A is 5, 7, 8 or 9 and even, it can only give you 8 as something that satisfies both. So therefore, A is equals to 8 and all the other pieces fall in place. A is 8, T would be 7, 1 plus H would be equal to 7 means that H is 3, and then S plus S is 8 plus 10 means S is equal to 9. So therefore, the number shake is equals to 9, 3, 8, 6, 0. Of course, we have already followed all the rules, but if you wanted to, you can always put all the numbers back in and check that the addition is really correct. In question 13, the diagram below shows a shape formed from 4 semicircles whose radii are distinct integers. The shape has a perimeter of 18 pi and encloses an area of k pi where k is a prime. And we're asked to find the value of k. Now the interesting thing you notice about this question is that it is ostensibly a geometry problem since there are circles, perimeter and area involved. However, distinct integers are mentioned and prime is also mentioned, which are usually conditions associated with number theory. And so this means that we should probably form the equations from the area and perimeter, but subsequently our approach is not necessarily to find it out using geometric principles, but rather using the number theoretic ideas, like how can k be a prime, is it odd or even, how do I make my radii distinct integers, and so on. So let's start by calling the radii of these 3 circles A, B and C. And if we know that the radii are A, B and C, that means that the whole diameter is 2A plus 2B plus 2C. And so that means the radius of the big semicircle is A plus B plus C. So now that we know all the radii, we can write the perimeter in terms of A, B and C. The perimeter is equal to 2 pi r for a whole circle. So pi times r for a semicircle. So pi A plus pi B plus pi C plus pi A plus B plus C. We can group this together as 2 pi A plus B plus C, and this is 18 pi. So therefore, A plus B plus C is equal to 9. Now we could also write the area of the shaded region in terms of A, B and C, and then compare that to K. However, we notice that radii are distinct integers and they sum to 9 is actually quite a restrictive condition. So So if any of you have done killer Sudoku or Kakuro puzzles, you know that 3 numbers summing to 9 doesn't give you many possibilities. It gives you 1, 2 and 6, 1, 3 and 5, or 2, 3 and 4, and that's it. So since there are only 3 possibilities, we can just check them one by one. For each possibility, we find the area, that tells us k, and presumably out of the 3 possible values, only one of them will be prime, and that allows us to determine exactly the value of k. So we check one by one. If it is 1, 2 and 6, the area is half times pi. So it's half pi r squared for each of those semicircles. So a plus b plus c is always equal to 9, since we have already established that. So 9 squared minus 1 squared minus 2 squared minus 6 squared. Quick calculation tells us that this is 20 pi. 20 pi is certainly not going to give you a prime number for k. 20 is not prime. So we try the next one, 1, 3 and 5. Again, we can do a quick calculation of what this would equate to. And if we do this correctly, it is 23 pi. So 23 is prime, and just to be safe, let's check the last one to make sure that we haven't done anything wrong. So 2, 3 and 4, do a quick calculation again. This is 26 pi. Once again, 26 is clearly not prime. And as a result, we can conclude k is 23. This is a useful question to illustrate why we cannot fixate on a single type of approach, because the diagram is obviously indicating we should use some geometry, and indeed we do use the formulas for the area and the circumference of a circle. However, if we keep on trying to look for more information about that, we're not going to get any further, because in fact, without the condition that they are distinct integers and prime, there would be arbitrarily many possible values of a, b and c, which could give you lots of different possible areas of your shaded region. So the only way that we're able to do this is to notice that a plus b plus c equals to 9 is a strict enough condition that we can consider just 3 cases of what the radii could be. In question 14, the sum of the 2 diagonals of a kite is 100. What is the largest possible area of the kite? For those of you who are already familiar with the formula for area of a kite, this is very straightforward. But in case it is new to a number of you, let's draw a kite. And there's a very simple way to get the area of a kite. Remember that a kite is a figure where the diagonals are perpendicular. So if you just draw a rectangle around it, it is pretty obvious that the area of the kite is half the area of the rectangle I just drew. And the area of the rectangle is just the product of the 2 diagonals. So half times the product of diagonals is the formula for area of a kite. Now that means that you want the largest possible area of the kite, means you also want the largest possible product of the 2 diagonals. So you want the maximum product. You want the maximum product, but you already know that the sum is 100. So when the sum is 100, in fact the sum could be any value, and you want to get the maximum product, this is obtained when all of the values are the same. So this means that both diagonals should be 50. And the area is just half times 50 squared, which is 1250. So this is a good reminder that the questions are not really in ascending order of difficulty sometimes. You can expect that all the way until the last set of 5 problems, there will be some easy questions sprinkled around. Finally, for question 15, we're asked to find the smallest 5-digit integer of the form 5x20y that is divisible by 33. We certainly cannot divide by 33 conveniently since x and y are unknown. We can't do long division in any reasonable fashion. We also don't have any divisibility test for 33, but we can actually split 33 into 3 and 11. By splitting it up into 3 and 11, we now can use the test for 3 and 11 separately, and collectively they should tell us the possibilities for x and y. So the test for 3, as we know, is that the sum of digits must also be divisible by 3. So 5 plus x plus 2 plus 0 plus y, which is 7 plus x plus y, is divisible by 3. The test for 11 is using the alternating sum, y minus 0 plus 2 minus x plus 5, and this is y minus x plus 7, is divisible by 11. We actually can find all possible x and y from here, and I'll leave that as an exercise. However, since the question asks us only for the smallest one should start with small values of x. So we could try small values of x and see whether the y's that result would satisfy both at the same time. Specifically, y minus x plus 7 is divisible by 11 is pretty restrictive already, because if it were to be divisible by 11 and x and y are digits, the only real values it could be are 0 and 11. So this is quite restrictive. Once I select x, I should be able to know I have one choice of y only to satisfy it. So let's try. If x equals to 0, then y plus 7 is divisible by 11. That means y must be 4. But 7 plus x plus y, which is 7 plus 4, is 11. That's not divisible by 3. Okay, so we can continue and try x equals to 1. If x equals to 1, then y minus 1 plus 7. So y plus 6 is divisible by 11. That means y is equal to 5. Now 1 plus 5 plus 7 again doesn't work. So this doesn't work. And if we try the next one, x is 2 and y is 6. Indeed, now it does give us a valid sum. 15 is divisible by 3. So therefore, this is the smallest one, and the 5-digit integer would be 52206. So this brings us to the end of this video, and in the next video we will look through questions 16 through 20.